Hello everyone, I am Manvi Singh, third year student of BSc Honours Data Science and AI, IIT Guwahati. In this video, I will be present my project Agriculture Yield Analysis and Prediction using Machine Learning, where I analyze farm level data, predictive model and deploy it is an interactive Streamlit web application. Agriculture depends on many interactive factors like crop type, irrigation, soil, season, and resources uses. Traditional farming decisions are mostly intuition based and lack precise yield forecasting. So our goal is use data driven machine learning to predict crop yield and support better farming decisions. So for this project, I use agriculture and farming data set from Kaggle and with 50 farm level record. Operation input include fertilizer usage, pesticide uses, water uses and irrigation method. Environmental context include soil type, season and farm area. The target output is crop yield in ton. So as you see, soil type is like sandy, loamy and season is kharif, rabi, zaid and farm area in acres and fertilizer uses in ton, pesticide uses in kg, and irrigation type like manual, drip. So this kind of things. Seasonality plays a crucial role in agriculture. This slide highlights the three major cropping season in India. Kharif crops are shown during the monsoon season from July to October, and Rabi are typically between October to November, and Z are grown during the summer month from March to June. Including seasonal information help the model understand how yield patterns vary across different climate conditions. This is based on the exploratory data analysis performed using the agricultureanalysis.py. I will show you this Python file. Okay, so this is our agricultureanalysis.py, and firstly I import the libraries pandas for data manipulation, matplotlib and cbol for plotting. Then I load the dataset and read the CSV into a pandas data frame. Then I print the first five rows and then after 5 rows of the dataset. Then after print the summary statistics, and this is our the plot distribution of numeric feature. These are the histogram, and this is the yield by crop type graph, and many more graph like this: average yield by season and yield distribution by irrigation type, and relationship between the yield and resources input like fertilizer versus yield, pesticides versus yield, water uses versus yield, and this is our correlation matrix. And there I use the heat map. Correlation analysis in this compute the correlation matrix for numeric feature and visualize it with a heat map and print correlation of yield with other numeric variable. So I run this file. Okay, so I am showing you, this is the current file, yeah. So our farm ID is this and crop type like cotton, carrot, sugarcane, tomato, and season like kharif, Z, and water uses in cubic meter like this. And this is our data type and object. And this is our summary statistics like mean, standard deviation, minimum, and max. All this value of season water and season. This is the water uses in cubic meter, and this is our correlation of yield with numeric feature, and farm area acre is 0.5 0.153 and fertilizer uses in turn like 0.04. Okay, and all these graphs are saved in here, agree plot. Okay, so this is correlation matrix, heat map graph this, and farm area, acre frequency, and farm area. And this is the fertilizer used in turn and frequency graph. Okay, this is the uh, drop type versus yield. And okay, so the results show that crops such as carrot and tomato achieve relatively high average yield compared to cotton and sugarcane in the given data set. And this is the another graph, irrigation type versus yield. And we analyze irrigation method. The result clearly indicate that drip irrigation has the high efficiency, followed by this is manual irrigation, while flood irrigation shows the this is the our lowest efficiency. Okay, so this observation support the idea that precise water delivery improve crop yield, whereas bulk water application leads to inefficiency. This insight from exploratory data analysis guided the selection of feature and justify the need for machine learning model. So one interesting observation from the data is that Z season, which is warm and dry, shows a higher average crop yield compared to the main Rabi and Kharif season. This suggests that favorable climate condition and control water uses during the Z season may improve productivity. And we also analyze the relationship between input resources and yield. Both water usage and fertilizer usage show a positively trend with crop yield. However, the relationship is not very strong, indicating that increasing input alone does not guarantee higher yield. And the scatter plot on the this shows a yield increasing with resource intensity such as water and fertilizer usage. Uh, the upward trend is more pronounced during this red season, highlighting better input efficiency. And the key takeaways that resource intensity influence yield, but seasonal timing play a critical role in determining efficiency. Okay, so now move toward the processing pipeline. And first, uh, and our uh, we are the so the processing pipeline, and I use the help of model training.py. I will show you. Okay, so this is our model training.py, and first import the this all libraries, and then this is our data path, preproducer path, model path, and result path. And firstly, we load the our data set in CSV file, and then build the preprocessor and categorical columns like crop type, irrigation type, soil type, season, and the numeric column is farm area, fertilizer, pesticides, and water uses in cubic meter. Then I evaluate the model, CV score, CV RMSE, and then I train the model. Okay, I use the three model: random forest, gradient boosting, and XGB regressor. Okay, so I run this file. Let me show you. Okay, this is random forest model, and RMS is 15.91, test RMS is 12.52, and R squared is 0.02, and gradient boosting is RMSE 19.82, and CVRMSE test RMS is 13.21, and R squared is minus 0.09, which is very low, and XGB regressor is also low. So best model is random forest. So I saved this model in PKL form and I used the random forest model for deployment. Okay, first I ingression, then preprocessing, one-hot encoding and normalization. Then I split the dataset, training set for learning purpose and testing set for validation. Then output is model ready array. So this is random forest regressor, gradient boosting regressor, XGB boost regressor. So I use the random forest regressor, which gives the better result than compared to this model. So the pipeline saved the highest performing architecture as best model.pkl form. I saved this model in pkl file. Okay, so this is our deployment page. I will show you demonstrate the deployed Streamlit application. So this is our main page, agri app.py for deploying page, Streamlit tab. So firstly, I load model and preprocessor, and I load the best model pkl file, then prediction function, and this is all. This is the button of this, and okay, I run this file. Okay. So this is our agriculture yield analysis and prediction app. Firstly, I explore the data analysis. This is average yield by crop type plot and yield distribution by irrigation type and average yield by season. And this is our data set, which in crop type, farm area, irrigation type, fertilizer used, pesticides, yield, soil type, season, and water uses. And there are two sections. First, exploratory analysis, and second, yield prediction. Okay, when I click this, so there are many sections like crop type. In crop type, there are barley, carrot, cotton, maize, potato, rice, soybean, all this crop type, and irrigation type, drip, flood, manual, rain fed, sprinkler, and this is our soil type, clay, loamy, peaty, sandy, silty, and this is season, kharif, rabi, sad, and farm area. Okay, so when I choose the maize and irrigation type is flood, soil type is sandy, and rabi season, I predict the. Okay, so this is and yield prediction, and predicted yield is 21.16 ton, and these are our plot yield versus predicted versus dataset average. Okay, this is predicted crop average, irrigation average, and season average. Also there are recommendation like consider high yield crop varieties, efficient irrigation method may improve yield, season selection impact yield significantly, maintain balanced fertilization. So this app like estimate crop yield, compare it with data set average and generate actionable recommendation. Okay, we already see the prediction to action, historical data set to predicted yield, and their recommendation like switching to drip irrigation may increase yield efficiency, and also input recommendation for cell dissolve profiles. We already see that. And project outcomes like clear data driven insight into agriculture pattern, a validated machine learning prediction model, a fully deployed interactive web application, real world decision support for farmer, and our future goal is to add the real time weather API and using the satellite imagery and integrating market price forecasting. So this is our future goal, successfully demonstrated the real world application of data science in agriculture. So thank you for watching, and this project demonstrate how data science and machine learning can drive sustainable agriculture. Thank you.